So this is the part 2 of the module. I will cover properties of UTP. Uh, so again, one property of UTP cables is that there are 4 pairs, 8 wires and then 4 pairs. Okay. Um, there is an outer jacket to protect the signal from noise and interference, and to limit crosstalk. Again, the way we define crosstalk are noise coming from its adjacent wire. Is they came up with twisting the wires. So in the history for before it's flattened, but they found out when wires are twisted, there is a point of cancellation effect on the noise and interference. There is a cancellation effect at the noise interference at the point of twisting. There are different standards uh, and connectors um, designed by EIA TIA. Okay, uh, there is this what we call standards for creating a straight rule crossover and rollover. These are under EIA TIA 568. I remember it right, A and B. Okay. Um, there is a laboratory activity for doing the straight through crossover and rollover. We will do it next term when we transition on the blended learning setup. Okay, we've discussed this. I had an overview of this in the on the first part. So again, under the cable type, so we have UTP, we have STP. Cable length again for twisted pair is 100 meters. Connector for twisted pair is RJ45. There, there's this for the phone. It's RJ11. That's the connector. Okay, and then the process of terminating the cable to the RJ45, you will be exposed on that hopefully next term. IEEE came up with standards of this what we call as category. In each of the category, so if a cable, twisted pair cable is under category 3, there are specific characteristics um, with that. And one important characteristic is the bandwidth. Okay, so in the evolution, it starts with Cat 1. Cat 1 is the phone line, and then there's Cat 2, category 2, then 3, 4, then 5, okay, and then 6. Okay, very important is this Cat 5, category 5, 5E, and 6. Category 5 has a bandwidth of category 5 has a bandwidth of 100 Mbps. Okay, again 100 Mbps. And then cat 6, category 6 is 1000 Mbps. Okay. Uh, Before cat 6, the demand of the 1 gig in the industry is high already. So since cat 6 is not yet being standardized, what they did is they came up with cat 5e. Cat 5e also has a bandwidth of 1000 Mbps. It's the same as with category 6. Okay, there. Again, these are the connectors we have. Okay. Uh, in the when we work on with the termination of twisted pair, when we do the straight through and crossover, we will observe yung proper ways of terminating the twisted pair cable to the RJ45. This is not good. Yung mga those wires should not be exposed. Okay, so there's a part in the outer jacket should be inside within the should be within inside the twisted pair. Sorry, should be inside the RJ45. Okay, there. Okay, there's a socket here. This is where we connect our RJ45. We usually see this RJ45 socket in the telecommunication outlet. So um, we have these different cable types: straight through, crossover, and rollover. We use straight through if we were to connect different device, different. Okay. So how can a device be different? If you recall, if you remember, when we discussed OSI, we've categorized network devices that a switch is in layer 2, a router is in layer 3. So if you were to connect a switch to a router, you use straight through. Okay? Also a PC to a switch, that is when we use a straight through. If you were to connect same device, say switch to switch, router to router, or PC to router. PC is the same as with the router because it has IP, like PC that has IP and MAC, so as with the router. Okay, so to create a crossover, we have these standards here designed by EIA TIA. Okay, so at one end of the wire, at one end of the twisted pair wire, the arrangement should conform to the T568A standard. Okay, and this is the arrangement. Okay, so on the other end, you use a T568B. Okay, so that is when that is how we create a crossover. As straight through, if on the other end is T568A, on the other side it's the same. It's T568A also. Okay, a rollover is a Cisco proprietary for console cable. Okay, for rollover, uh, you use a T568A. On the other end, it's the opposite of T568A. That's how we create a rollover. So meaning, on the other end of the wire, for a rollover, this 8 here is pin 1, this is pin 2, pin 3, pin 4, 5, 6, 7, 8. That's how it is for a rollover cable. Okay. Again, next term, we are to explore these different cable types. Uh, Twisted pair is prone to interference. Okay. Uh, and also, if we were to look in the market, like as of now, the bandwidth that Twisted Pair can provide is up to a 10 gig. There's already a Cat7 actually in the market, a 10 gigabits per second, no, within that range. If you were to Google, there are cables that has a bandwidth of 1 terabits per second, 1000 gigabits per second. These are fiber optics. Okay, so the good thing with fiber optics is it can provide a much higher bandwidth. Another, there is no EMI RFI. Okay, there is no interference. Well, because fiber optic uses light signals, and by physics concept, light travels faster as compared to electrical, as compared to sound. Okay, there's also less attenuation in fiber optic. A fiber optic can go to a range of a kilometer, of up to 10 kilometers. So, uh, so this is ideal for scenarios where there is long distance and there is a demand for a higher bandwidth. Okay. Another is, since it uses light signal, we expect that in the LAN card, there's this light source. Okay. Uh, Again, the fiber optic cable is, it uses light signal. It transmits light between two ends of the device. Two ends of the cable, sorry. There's two types of fiber optic. We have the single mode and multi-mode. In a single mode, the light travels in a single path. With this, it can cover to a much longer distance, okay, like up to 10 kilometers. Usually, we use single mode for long haul types of network. Example, connecting the connection, specific connection, say from one country to the next country. Like example, I remember in the Middle East, say connection from Kuwait to Saudi Arabia, okay, to Bahrain. There, that's one example where single mode fiber optic is used. So a fiber optic usually consists of two parts. You have the core made up of fiberglass. This is where the signal travels. And then this core is protected by a cladding. Okay, a cladding, and then part of the cladding is this polymeric coating. It protects the uh, signal from encountering issues such as reflection, refraction, absorption, or other issues in the fiber optic cable. Okay, the light source for single mode is LED, light emitting diode. In the multi-mode fiber optic, light travels in multiple paths. Okay, um, it single mode can cover much longer distance as compared to this multi-mode. Say multi-mode around 2 kilometers. It has a much larger core. Okay, and then just like with single mode, it has a cladding, okay, a coating also at the outer part of these fiber optic cables. Okay. Fiber optics nowadays can go to a range of like a terabits per second of a bandwidth. So fiber optic, we do know that it's now used for home internet, right? So this is one option, fiber to the home. It can be used as backbone cables for enterprise. Backbone or vertical cabling, say connecting, this is in connection between, say backbone switch, that is your centralized switch. Usually this switch, which is the center of your network, needs to have a higher bandwidth. Usually its port has a higher bandwidth. So for example, let's say the port that this switch has is a 1 Tbps. So in order to ensure that there is a smooth transmission, consistency in the bandwidth, you need to have a cable also that provides a 1 Tbps bandwidth. Okay? Um, and that is when you resort to a fiber optic cable. Okay? So another is fiber optic may be used by service provider, by telco, say for example, a telco in Saudi Arabia to connect to another country, say in Bahrain. There is this also cables uh, installed under the ocean, say Pacific Ocean. We will explore on this during our live session. It is called the submarine cables. It connects. Uh, these are installed by telco, by service providers to connect from one country. Say PLDT has the submarine cable to connect to other countries for our, and its purpose is mainly for our internet connectivity. These are some of the fiber optic connectors we have. Okay. And then there's also patch cords. Here I have in this slide. We don't have termination for fiber optic in the CCNA. Usually equipment we use for fiber optic termination are very expensive. Okay, so that's why it is beyond the scope of the CCNA program. So to sum it up, again, fiber can provide a much higher bandwidth and can cover at a longer distance as compared to a twisted pair or coaxial. Okay, but the twisted pair is the cheapest and easy to install. Okay, so based here, based on what we've discussed, we've seen that in each of these types of cable there are disadvantage and advantages.